Okay, today I'm going to talk to you about investigating osmosis. I'm going to talk to you about a particular practical that you can do in order to find the concentration of sucrose in a potato. So, what we're going to do is, if we remember first of all, osmosis is the movement of water particles from an area of high concentration of water to an area of low concentration of water across a partially permeable membrane. So, if you're unsure about that, please watch my other video about osmosis. So first of all, I can get a cork borer. Now all this does is I can use this, I dig it into the potato, and I can take cylinders of potato out like this. Okay? So I'm going to end up with a few different cylinders of potato. Now, what I need to do is, before I do anything, I need to measure the mass of these potatoes. So I'm going to put them on an electronic balance. Put it on the electronic balance like that, and I measure the mass in grams, okay? Now, what I'm then going to do is I'm going to have a few different solutions. Each solution is going to have a different concentration of sucrose in. So let's say here are my 4 different beakers. So, all these different potato cylinders from the same potato, everything else is kept the same. I want to use the same amount of liquid. The only thing that's different between them is the percentage or the concentration of sucrose. So let's just say this one has 0% sucrose. That means it's pure water. Let's imagine this one has 10% sucrose. This one has 20% sucrose, and this one has 30% sucrose. So I've just taken all of those 4 different cylinders, and for each one, first of all, I measure the mass, and then I put them in the solutions. Now, what I do next is I need to leave this for at least 40 minutes. Because what's happening over that 40 minutes is I could be having a change in mass. If the concentration of water is greater outside the potato than it is inside the potato, there's going to be a net movement of water in. If the concentration of water is greater inside than outside, then it will move out. So we're looking to see the change in mass. Is the potato going to get lighter or less mass, or is it going to gain more mass as water enters? So let's imagine when I measured the mass of each of these on the electronic balance, let's imagine each of them weighed 10 grams. So here's my different concentrations of sucrose. SC just stands for sucrose concentration, but I didn't have much room to write. So initial mass, let's say all of them started off weighing 10 grams. The word initial just means at the beginning. So I leave these for 40 minutes, and then after I've left them 40 minutes, I take each one out, I dry it off. Now it's important to dry it so I haven't got any extra mass of water, and then I've remeasured the mass using electronic balance. And let's say I got these results here. My final mass was 15, 13, 11, and 9. So this one increased in mass by 5 grams, and this one decreased in mass by 1 gram. So the first thing I need to do is I need to find out the change in mass. So to do that, you just do the final mass, take away the initial mass. So this one was 5 grams, this one was 3, this one was 1, and careful with this one, the change in mass, because it's gone down, we're going to show it as -1. So what we need to do now is we need to figure out the percentage change in mass. What percent has it increased by, or what percent has it decreased by? In order to do that, we need to use this calculation here. We need to do the change in mass divided by the initial mass. Remember, initial mass just means the mass at the beginning, and then multiply it by 100. So for this one here, so the change in mass was 5, the initial mass was 10, and then we multiply it by 100. So this one has increased by 50%. That's because it's in pure water, the concentration of water is greater outside than inside, so the water molecules have moved in, increasing the mass of the potato. Next up, we use the same equation, change in mass, which is 3, divided by my initial mass, then multiplied by 100, so that one's had a 30% change. And I'm just going to do these ones in my head, or that one in my head. Now this one, please notice as well, the change in mass, because it's -1, we need to factor that in. So -1 divided by, -1 divided by 10, because that's the initial mass, multiplied by 100. So this one has a -10%. It's got lighter. The reason why this one has a -% is because water molecules have moved out of the potato. Because the concentration of water molecules is greater inside than outside, they are going to move out. Okay, so what do we do next? Now, the clever thing we could do is, at the moment, we don't know the concentration of sucrose within this potato. So what we have to do is we actually have to plot a graph. So here's what the graph would look like. The concentration of sucrose goes across here. This could be in percentage, or it could be given in moles, in molarity. And the change in mass goes up here. So here's a positive change if the potato increased in mass. Here's a negative change in case it decreased in mass. So let's just quickly see our results. So at 0%, sucrose, it has increased by 50% mass. At 10% sucrose, it's 30. Now you'd be doing this on graph paper, it's just graph paper doesn't show up particularly well on here. At 20% sucrose, there's been a 10% increase in mass. And at 30% concentration, the potato has actually decreased by 10%. So you've now got a graph. Now, what you can do is you're going to draw a line of best fit. Now mine isn't going to be perfect because I haven't got graph paper. But there we go, a line of best fit between them. Now, if you see this point here, this is really significant. Because this point here would be the point at which the potato didn't increase in mass and the potato didn't decrease in mass. That means that the water concentration of sucrose was exactly the same outside the potato than it is inside the potato. So there's no net movement of water. So that point there on our graph shows us the concentration of sucrose in the initial potato. We've used our other results to show the pattern at this point here where there's no net movement of water because our potato hasn't gained mass or lost mass. This must be the concentration of sucrose in the potato. So we could see from here, it's halfway between 20 and 30. So this one here would have a 25% concentration of sucrose in the potato. So that is how we investigate osmosis. Thank you.